Okay, in the first 2 days of this chapter, I taught you the basics. Now we jump into applications. Like word problems all the way through this semester, when the diagram or equation is given, life's pretty straightforward. When the diagram is not given, then the game is on. Okay? So, for each of these problems, we need to draw a well-labeled diagram. Include a let statement when needed. Show all your work, including which trig ratio you're using. And word problems require word answers. So if it's a word problem, you got to give an answer in words. Already into the first example. What kind of triangle are we talking about here? Look at the information and tell me what kind of triangle this must be. It's a right angle. I can see it's got a 90 degree in it. That'll help me to draw the diagram. An extra what? Yeah, I don't have one right now. Okay. Situations like this, at first glance, you might be like, okay, what do I make A, B, and C? Well, there's some hints there. Shh. AC is 4, BC is 1.5, and B is 90. Which of those is actually helpful in labeling my diagram? B being 90. Okay, so now I've got that much at least. And the other part, it might be troublesome. You look at it and go, well, what do I put A up there? Do I put C over there? Like, where do I put the A's and C's? And it won't matter. Your diagram might look different than other people, but you'll get the same answers. I'm choosing to go A up here and C there, but I have no information to make that choice. I just went, okay, I'll just make A over there and C over there. If you go the other way around, you will get the same answers. That helps now, because AC is 4, and BC is 1.5, and they say solve the triangle. That means find all the angles and sides. Well, that's interesting, because you might freeze a little bit. You're like, well, what do I go after first? My answer in all geometry problems is whatever you can find. Find something. Looking at that, what can you find in the triangle? Three right answers. A to B. She says, I can find A to B. I could find it before I took grade 10 math. Okay? I'm going to label that X. Do you see it now when I put that X on there? You can see this is just a Pythagorean theorem part of the question. So I can go, okay, X squared equals 4 squared minus 1.5 squared. You get your calculator out. You go 4 squared is 16. You go 1.5 squared is 2.25. You subtract those, and you get 13.75. And how do you undo squaring? Square root, she did the little hand signal for square root. Her little finger went dee, 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 like this. Square root of 13.75, which is,
3.7.
Did you do it? 3.7? 13.75 equals, crazy answer, 3.7. Here's my little hint. When solving triangles and doing this work, as soon as you find something, put it on your triangle. That will really help along the way. It's just go here, oh, now I know that side's 3.7. If that was a grade 9 question, that would be the end. We'd now be done. But it's not. It's a grade 10 question. So it says solve the triangle, which means find everything. Find the angles, find the sides. So I switch now to grade 10 math. I'm going to find an angle. I can find either angle. Which angle would you like to go after first? If you're going after C, circle it. in grade 10 to go, this is the one I'm working with, because that will change your labels. Which side is the hypotenuse? How long is it? 4. And which side is the 1.5? That's adjacent. Somebody might go, well, can't I use the opposite here? You can. You'll totally get the answer. It totally works. Generally speaking, what we do is we try not to use calculated values if we don't have to. What if I made a little mistake here? Then my mistake would follow over to C. Okay? You can't always do that. Sometimes you're stuck with using what you figured out already. But if you can avoid it, that's one less error that might happen. So I'm going to use adjacent hypotenuse. If I'm using adjacent and hypotenuse, which ratio? Cosine, yeah. I know some of you are still calling it cos or cos. This doesn't bother me really, but I keep moving forward to saying it's called cosine. I know it's a short form. Yeah? Shh. Cosine of C is adjacent over hypotenuse. If you haven't got that memorized yet, probably time to start panicking for this upcoming quiz. Yes? We need that memorized. How do we memorize it? Does anyone remember the word? What is it? SOHCAHTOA. That's the memory tool that you're going to need on the quiz. Often we make that the first question of the quiz. We say, what's the fancy word that you need to memorize to do right angle triangles? And you just write SOHCAHTOA. Yeah? I can tell you though, if you don't memorize SOHCAHTOA by the time of the quiz, well, it won't take me long to mark your quiz. And math and science can be like that the rest of the way. There are some things that are vital information. If you don't have that, dead on the quiz. Question?
So like when you're trying to find the C, why do you use adjacent and
I could have used opposite. I had opposite, I calculated. I made the decision to go, well, that's a value I just figured out. So on the off chance that I made a mistake there, I'll use the ones they gave. If at all possible, I try to use the ones that are given. If you got them all, though, you're right. I could have just as easily done tan here. I could have just as easily done sine. Any of them would work once you have all three sides. Yeah. So what is adjacent? What's its value? And hypotenuse? Hypotenuse is 4. Okay, but then what do I do? Well, I'll teach this slightly different than I did yesterday. Do you have C? That's what you're trying to figure out. So I can't type that in. I can't type cosine C because I need the angle. That's the hint to go, no, don't use cosine. Move that over and make it cosine inverse of whatever's there. Make sure you're in degree mode. It's not funny on quiz day to reach over and put people's calculator into out of degree mode. It's definitely not funny. Don't let my smile fool you. It's not funny.
It's not.
It's not funny. Get every single answer wrong on the trig quiz because you're not in degree mode. 68 degrees. I like drawing lines when I found stuff. Like, woo, done. But it said solve the triangle. It said find everything. How now would you like to get angle A? Yeah, just you can write this any way you want, but essentially you're just going to find angle A by taking 180, subtract the 90, and subtract the 68. Could you go through the whole sine, cos, tan thing to find the other angle? Yes, but I'm trying to throw all the weapons in there. What's that? Well, you're right. This will only be as accurate as I was here. But I'm trying to use all the weapons here. Any questions on that? Do you need more time? Example 2. In a newly built home, the vertical height between two floors is 2.5 meters. And the horizontal length of the staircase is 22.8 meters. How you like my set of stairs? I don't know. In a new we-boat home, the vertical height, there, 2.5 meters. That's how far it is from one floor to the next floor. That's why they're called floors. Yeah? Next, the horizontal length of the staircase is 2.8. Staircase is 2.8 meters wide. Determine the slope of the staircase. Wow! Little chapter 2 action going on here. How do we find slope? Rise over run. Okay, so just a little throwback here. Slope equals rise over run, which is 2.5 over 2.8. And I'll get it as a decimal. Not that I really need to, but just to get the gist of it. 0.89. Okay, that's old news. B, determine the angle of inclination of the stairs. Okay, I need one more line on here. I'm going to do it in green, blue. I will do blue. There's the angle of inclination right there. It's not the hypotenuse. It's the angle in there. That's what I'm after. Is this?
You have to use tan.
She says tan.
I just wrote that.
Why tan?
Because we have the adjacent and the opposite.
Once I've labeled, I know I'm after A. This is adjacent. And this is opposite. So tan of A is opposite over adjacent. Tan of A. What's that? Invert it. And if you're like, why are you doing this -1 thing? What advice to somebody would you give who says, why are you doing the little -1 thing? What the heck does that mean? Do you have some life advice for them?
Yeah, you take it over the equal, and that you have to flip its operation around.
Oh, okay, that's absolutely true. Tan moves over and becomes tan inverse. It's its opposite operation. That's true. But for someone who got to this point, what would you say to them to do next if they don't know what I'm talking about here with the -1? I'd say watch yesterday's video and do yesterday's homework, or at least some of it at this point, because that's supposed to be, I got that. Okay, what did I forget to do here, friends?
What do you mean?
What do I mean?
Your lex statements or your answers.
Oh, yeah. Some words here. Let me tidy this up. Therefore, the slope is 0.89. Therefore, the angle of inclination is 42 degrees. See, word questions should have word answers. If they're algebraic questions, well, then I guess I'm okay with algebraic answers. Do you have any questions about the staircase? Do you need more time?
I just found out today that Finland is the best country.
Here's some information you're going to need for the rest of the chapter. Angle of elevation, angle of depression. We just called that angle of inclination. I just threw that in the last question. But angle of elevation, take a look at this picture. Wherever you are, if you're looking outwards, angle of elevation is always from your horizontal up to something. Angle of depression is always from your horizontal down to something. Now some of you are nodding and you're smiling. You're like, okay, no problem. I can tell you, every year in the test, a couple people call me over and say, Mr. Todd, which one's the angle of elevation again? I'm like, no. Test day is not when I answer questions. It's when I ask questions. Yes? This better appear on your study page so that you're studying this and going, yes, I know which one's the angle of elevation, which one's the angle. A search and rescue airplane is flying at an altitude of 1,200 meters towards a disabled ship. Oh, okay. Here I go. Here's my picture. Airplane? Not bad for me. Does it look like an airplane?
Yeah.
Not bad. Not great. Not great. Not bad. Boat, disabled boat. Here comes boat. Boat's easier. Oops. Then I messed it up. Boat. Our search and rescue airplane is flying at an altitude of 1,200 meters. So, I like labeling them sideways. I don't know why. If it's going to let me. Crazy pen. It's not going to let me. 1,200 meters towards a disabled ship. The pilot notes the angle of depression. Here we go. Where does the angle of depression go? From the plane down. So it's here.
The angle of depression?
Yeah, 12 degrees right in there. That might not be convenient to you. The altitude to me was there. The angle was here. I'm going to have to do a little thunking here to get this all figured out. Well, there are two ways to do this question. Olivia's randomly shouted out the number 78. What the heck is she talking about? There's no 78 in the question.
So basically why it is because that's a right angle, so then 90 is 6.5.
She says this is a 90, so I can get this one here and make that 78 in there. And then I'm into the triangle that I think I want.
Wait, repeat that.
Wait, on these questions, will the other angle always be 92? So then you have 90 and 78.
Yeah. That's one way to do this question, is to go, I'll go into that bottom triangle. I must tell you, it's not the way I would have done it. What would you have done?
No, like, I'm just asking, like, why is the 12 on the outside?
On the previous slide, I showed that the angle of depression is always from the horizontal down to whatever you're looking at. So that's where the 12 degrees goes. So if I'm going to use the bottom triangle, which I could use, Olivia goes, okay, make that 78.
Also, then that angle is also 12. So if you think about it, it's like square.
Yeah. She says, oh, I could use 12 over here as well. It's not the way I would have done it, I must tell you. I would have kept the 12 and just moved that 1,200 over to here. And it worked in that triangle. I don't know that I'm right. I actually don't know what the easier way for you to do it is. All I do know is there's not a whole lot going on here. You just got to make a decision on what you're trying to find out. Because it's basically a big rectangle that we're talking about. Yeah? So I'll do what she said. I'll stick with what she said in 78. And what I really want to know is this distance down here. And I'm going to call let x equal the horizontal distance to the boat. Okay? And if we're using the 78, I'm going to circle it so you know what I'm up to here. What's 1200 called? The adjacent. Adjacent. And what's the x called? Opposite. Now I can go over here and do some trigonometry. If I have adjacent and I'm looking for opposite, tan. What angle are you using today, Olivia? 78. And if you do this question differently, you might be using the 12, and that's okay. You'll get the right answer. It'll work out, even though you're using a different angle, because you'll use a different ratio. Tan of 78 equals opposite over adjacent. What's the opposite? X. What's the adjacent? 1200. And this is from 2 days ago now. But I'm going to teach it differently than I did those 2 days. I'm going to try to help now that we're on day 3. Can you type tan 78 into your calculator? Yeah. So go ahead and do it. Okay? We don't need the tan inverse here because I can type tan 78 in. The way we set this up helps me to understand whether I'm going to use tan or tan inverse. I get 4.7046. And does anyone know what the last step of this then, what should I do now? Multiply. Take 4.7046, multiply it by the 1200.
It equals 5,600.
Times 1200. I'm going to type it in for the sake of the video though.
Yeah, you got that.
5645. And I think maybe I can explain why 4 decimal places now in this example. 4 decimal places meant 4 significant digits. I wanted my answer to have 5 significant digits. Maybe 4 wasn't even enough. See, when you start multiplying it by things, if you want to keep 1 decimal place, you better keep at least 4 when you're doing the math, depending on what you're multiplying by. Maybe 4 is too many, but it's not easy to know when you start the question. So in 10, we just say, use 4. We'll be happy with 4 for now. When you go out and do physics or engineering or chemistry or biology, you can decide then in the particular question what's enough decimal places. Therefore, the horizontal distance is 5,645.6 meters. Future science people, maybe 4 decimal places wasn't enough here, but in grade 10 we're just going to live with it. Maybe I should have been 5 decimal places to get 5 significant digits, but well, we just won't jump off that cliff just yet. Do you have any questions about this airplane question?
Wait, Scott?
Yes.
Why? How did you say you could do it the other way?
I could have went over here and used this as 12. And I could have used the opposite of 1200 and solved for the adjacent, and it would have been the same. I would have had to divide instead of multiply to get the answer, and I would have used tan of 12 instead of tan of 78. But you just have to believe me, math is not broken. It would have worked just as easily, yeah.
If it was like, instead of like fly directly above the ship, if it were to fly like directly to the ship, would it be coast?
If you want to go directly to the ship, if you're going to, head to land there, then we'd be after the hypotenuse. And all that would change we'd probably be using cosine or sine to find that, but they wanted to go directly above the ship. So what they really wanted was this distance, but that's the same as this distance, so, not overly complicated. Questions? More time? How many more is there to go? You seem restless to me. 2 more to go. All right. Example 4. This one's actually a little complicated, so if you've fallen asleep, Maybe you should play along a little bit. Jackie works for an oil company. She needs to drill a well to an oil deposit. Jackie's drilling for oil. The deposit lies 2,300 meters below the bottom of a lake. Huh? Let me draw the lake on here and give you an impression of how complicated a situation here. Here's the lake, and there's the bottom of the lake. Do you see what I mean by a lake?
Yeah.
Jackie's over here going, how am I going to get to this oil? And this is how they do it. He goes over here and goes, because you don't want to drill down through the water if you don't have to. Yeah? We do it in the oceans. Like we put big rigs in there, and but whoa, that is a lot of trouble. Instead, Jackie's plan is to go, oh, where's the oil? The oil's down here. O for oil. Jackie's plan is to go, I'll just take this drill and put it in at an angle. Doesn't have to, the water doesn't have to be a problem. Boy, you better get it right. You don't want to drill into the oil, I guess, or into the water, I guess.
Wait,
But some lakes aren't too busy, aren't too deep, I say. So maybe you can picture it more like a pond. You know, it's going to go underneath the pond, and there's some oil under there. Good so far?
Yeah, is that
The deposit lies 2,300 meters below the bottom of the lake. Okay, so this distance here, 2,300 meters. Yeah. And the water is 150 meters deep.
Okay, now you're just showing off. Start with the little thing.
the little curly bracket, they're fun. Practice them a few times. First few times, like, and then it goes faster. Look on your the keyboard, any keyboard. You'll see little curly brackets. They're out there, handy. The site is 1,000 meters away from a point directly above the deposit. So let me just add one more line here. And now we're going to need somebody.
Even ask us a question. It just gives us the example, but it never even says what we're solving for.
That means you have to solve for angles only.
Yeah, you're right. It does not say. What angle? Should she drill at? What angle of depression should she drill at? Okay, well, she's after this angle here, this angle of depression. We're going to call it angle A. And what do we have? What's the 1,000?
That's adjacent.
Adjacent. If that's not starting to come to you, oh boy. Yeah? What other, do we have the hypotenuse? No. Do we have the opposite? Kinda.
You just add them together.
Just add them together. Okay, well, yeah, okay, that's not too bad. With a good diagram, this isn't too bad. So this,
As he shows off.
2450. So we're doing O and A. OA. What's OA? Tan. Yeah. Tan of A is opposite over adjacent. Tan of A is 2450 over 1,000. And here's me teaching it differently than the previous 2 days to try and help you out. Can I type tan A into a calculator? No. I have to invert it. So if you don't have what you're looking for, you've got to move the tan over, and when the tan moves over, it becomes tan inverse. Now, it could be that woke your brain up just a little bit, the way I said that, because you're like, oh, add becomes subtract when you move it over. Subtract becomes add when you move it over. Multiply becomes divide. Divide becomes multiply. Squared becomes square root. It's just the same stuff. It's just tan becomes tan inverse. Anyone type this into their calculator?
Yeah, it is
Tan inverse
22.
2450 divided by 1,000. Did you get 68 degrees? Okay, let's just touch your brain a little bit. What angle should she drill at if it was 1,000 and 1,000? What angle would it have been? Don't use your calculator, just think about it for a minute. If it was the same both sides, what angle must it have been? If two sides are the same, that's 90. What will this angle be? 45. So the fact that this side was longer and this came out to 68 makes sense in my brain. It should be more than 45 if you got to drill farther down than over. Okay? Anyhow, back to here. Is nearest degree going to be close enough to hit the oil? That I don't know. I don't drill for oil. Maybe over this distance they would need 68.1 degrees. They'd need exactly so that they make sure they hit the oil deposit. Maybe oil deposits are so big, as long as you get it close, you're going to hit the deposit. I guess I don't know. Physically, I haven't done a lot of drilling for oil in my life. Yeah? The best I've done is pour oil into a motor. Yeah, that's the best I've done. Yeah? So. We'll leave that for when you become an engineer. And you go, oh, we need extra decimal place here, which isn't a big deal. We could have just got an extra decimal place. Yeah? Anyways, what do I forget here? Therefore, the angle of depression is 68 degrees. Don't let the depression word scare you, because right in the sentence we also have an angel, so everything's going to work out. Angle. Reese, how many more? One more. Do you need more time? I'm ready. Are you ready? Jimothy is standing 30 meters away from a flagpole. Jimothy. Flagpole. Straight line.
You go back to the shoulder. Yeah, I don't know. That's weird.
All right.
I don't understand
Yeah,
throwing me off.
and it throws, and you know, and it can cause a problem, and people get really, really very annoyed with me when they get their test back and they don't get all the marks here, and I totally understand why. Let me just show you what I mean. There's the, oh, that's not the eyes. His eyes, right about there. There's the triangle that we're talking about. That's the only thing you got to do with the eyes. Well, that's a complete lie. We're going to have to do something at the end to get the answer, okay? But that's where the triangle is. Jimothy is standing 30 meters away. So this is the 30 meters right there in the triangles. The angle of elevation is 40 degrees. Just going to leave a little room for the 40 degrees in here. Jimothy's eye, okay, good. Everything's good. I've ignored Olivia's concern about the 1.5 meters. I said, I don't know. Now I'm after that much of the flagpole. We don't like that color. We need black to be able to see it. There we go. Which I will call X. Relative to the 40, what side do I have? Adjacent. What side do I want? The opposite. Oa. Oa. Toa. 10. 10 of 40 equals opposite over adjacent. 10 of 40 equals x over 30. Here's my new way of teaching today. Can you type 10 of 40 into your calculator? Yeah, you can. You've got the number. So go ahead and just type 10 of 40. You don't need 10 inverse if you got the angle. 10. 8391. Then, how do I get x?
You have to
Times it by 30. Times 30. Israel says it's 25.2. Which is not the right answer.
Why is it up there?
That's how
Oh, we
far
need
the
to add them. We need to add 25.2 plus 1.5.
That's where the 1.5 comes in. Not a big deal when you do it from your eye level. And actually, this is part of the deal when measuring trees and faraway things. You go, well, yeah, but how much am I off the horizontal? And then you just add that in. It's not really a big problem. You just can't forget to do it. Yes? H equals 25.2 plus the 1.5, which is 26.7. Therefore, the height of the flagpole is 26.7 meters. Do you have any questions? This is really easy, Ms. Todd. I know. It's easy to watch these lessons and go, I totally get it. It's going to be fine. It's not going to be fine. This is easy if you practice it. It's not easy if you watch it. There should be twice as much practice going on. This will go so well, you can get just a beautiful mark on this test. If you just do the practice. It should be, you know, handed in halfway through the test time. It's like, bang, done. If you're not fast at it yet, just do a few more. You'll get faster.
Can I go grab my homework?
Yes. Now, one other thing I want to tell you. We have an upcoming quiz. What's today? Your quiz is on Thursday. What kind of things are on the quiz, Mr. Todd? Well, I've got a practice quiz for you in just a second. What's the problem with Thursday? You're very upset. What's the matter? Wait till next Thursday, the day before Christmas. Wait till you see how many teachers drop a quiz or test on that day. Got to. Can't let you take 16 days and forget a whole bunch of math and have the test when you get back. No, that doesn't work.